So do you guys remember the super old console that came out like 15 years ago? Yeah, the one which had a freaking gun in it. It was my favorite console, and that console had a game called Duck Hunt, which was by far my favorite game ever, simply because you have a physical gun and you actually have to shoot them. And nowadays there are quite good games, but it's just not the same. Now I know I can get something similar inside a VR, but VR is expensive and I don't have any money, but I am an engineer, so let's build it. So I'll build the game using Kaboom.js and run it on my local computer. But we also need a gun. So for that I'll use Node.js to serve two web pages, one on my computer, the Kaboom.js game, and the other one, the gun, to my phone. Now how do I connect both of them? Simply using the router. So my computer gets a local IP from my router. I'll use that IP to host instead of using my local host, which will allow my gun to connect to my computer using the router. Let's dive into the gun a bit more. So I'll create borders using red color which don't exist anywhere else inside the game, so that I can recognize where exactly the game lies inside the frame of each photo. Now this photo I'll send back to the computer and then figure out based on the coordinates inside the game and the photo recovered from the gun, if the center point of the gun is at the same coordinates as my duck, then it's a hit, otherwise it's a miss. Turns out this is very difficult because if you're too far, the gun won't get the coordinates properly. If you're too close, the gun won't be able to see the entire frame, which again means you won't get the coordinates. Plus, it's really difficult to map out the coordinates because sometimes the picture is distorted because of my curved monitor. In the end, I dropped the idea and looked for a solution, and I found this really useful video.
How did Duck Hunt work? Well, when you pull the trigger, the entire screen turns black for a fraction of a second, except for white boxes wherever the ducks are. The zapper can tell if you're pointing at one of those boxes and registers a hit.
So now let's use the same concept that was used in the original game and build our own. So instead of tracking at the entire frame, I'll just track the target, just like the original game. So what I'll do is I'll create a target in a unique color, let's say red, and then only track red pixels in my gun. If at the center of the gun there are red pixels, which means we have a hit. If there are no red pixels, then it's a miss. Now, I don't need to send the entire image back to the computer. I only need to send a hit or a miss. Now let's talk UI. So I am not a very good UI builder. I tried to build my own duck UI, but I failed miserably. Also looked for some options on the internet, but they were really low res. And finally I found this website from Kenny and settled on these two extension packs. First one is for the UI and the other one is for a platformer game. But I'll think we can make do with these. Now the ducks which we have don't exactly look like regular ducks, so let's just say they are alien ducks. Now before we jump into the code of the game, let's take a look at what I was able to build. So on my first run, I wasn't able to hit anything. I was aiming correctly, but it wasn't recording any hit or miss. Turns out every camera has a different color profile. So the camera which I used for testing was different from the one that I was using in recording. So I had to tweak the colors based on this phone's camera, and then I was able to hit the targets. And in fact, I became John Wick. After first successful run in the game, I tried checking off my phone just to see how durable my gun was. And turns out it was quite durable. So I moved on and again went to shooting some more ducks. Finally, let's see how you can also code something similar. So this is my entire project structure. Let's start off by creating this package. Simply use npm init to create this package. After that, add the following packages because we will be needing them. And then you can create your own certificate for SSL. Next thing is this JSON-DB, because we need to store our high score and we don't really need a full-fledged database, so I'll just use this. And finally, we have our index.js, which is our entry point of our node application. I'll add the imports at the beginning, then create an express app, use codes, and then set the static folders, which basically serve static files, then set a path. Now this is really important because we will be serving our static files in this game and nothing else. Next, I initialize my JSON database and then created two endpoints, one for my gun and the other one where the game will run. Next, created an HTTP server with my certificate so that it can run using HTTPS. And finally, we need to listen on a port. Keep in mind, I'm using the IP provided by my router so that all the devices connected in the network can access the server. And finally, we need to set our socket. Now let's move to our asset loader. This file basically will load all the sprites and sheets that we will be using in this game. But let's start with a font, then with a complete tile sheet. Now this is the tile sheet that I am using. I don't need all the tiles, but I need a lot of them. So I've created an animation and each animation represents a tile. Now I won't be using it as an animation, I'll use each individual tile, but instead of adding them individually, I add them together. Now I need to add 3 types of enemies, so let's do that same way we did this one, except we will have animation that will actually be animations. Now I have 2 animations, one for flying, one for dead. Now let's add some more sprites. This time I'm adding single sprites because I have a single PNG and this is for the UI. Also, I have added a crosshair at the end. Okay, now let's create the scenes. We have 3 scenes, one for menu, one for environment and one for game over. Now let's move to our main.js. Main.js will be our main Kaboom file. So we will import our Kaboom.js here first and then we will initialize our Kaboom. Now let's add the asset loader and load all our assets. Next, we'll import all the scenes which we created and then add them. By default, we will start off using menu. Now let's move to the menu. In menu, first we'll make this function. This will help us to get the tiles from the animation. Next, we'll add the background. So this background consists of 3 images and I have added all those 3 images to form the background. Next, let's create a map. This map will be used to create other elements inside our map, inside our view, and each element is created using different layer. Each layer will occupy different axis on different place on Z axis. So we can add 2 to 3 layers to add all the things. So the first 2 were used for grass. I wanted them to overlap. So the first 2 layers were for grass and the third layer is just for the base, or let's say the ground. Now we will render all these layers. Next we'll add some basic menu sprites, buttons, and finally we will add our crosshair. This will follow our mouse and wherever we go. Next we'll add an on-click event. Now this on-click event will take us to our different scene, which is the world, whenever the play button is clicked. Now let's go to the world or the environment. So first off, we need the basic scene. So I'll add all the things that I added in our menu and then I'll add some other details. So first up, we need some variables. So let's create those. We have live, speed, score, paused, and change direction. Change direction is to decide when our enemy will change the direction. Speed is our this base speed of our enemy. This can vary based on the type of enemy. Next, let's add a function to toggle our pause. Finally, we'll create a method that will generate our enemy. So this basically randomly chooses one of the 3 types of enemy and then adds them. Now this has a speed factor which will allow us to change the speed of the enemy based on the type of the enemy. Next, let's add a crosshair here as well to keep the consistency in the UI. Finally, let's add some text. So score, lives and high score. You can see there is no high score in this file, but we will create it in our index.html and use it here. Next, we'll add a dead function to kill the enemy. Here you can see I'm emitting the score using this socket, and also I'm calling destroy enemy and generate enemy after some time. Next, let's create a on click event. This is to kill the enemy if someone clicks on it, just in case if you don't want to use the gun and kill it using your mouse. Next, we'll create the most important method, that is the update method. This will be called to update our enemy every frame. So here comes a lot of logic. So first off, if it's paused, then we don't do anything. We don't update it, we don't change the animation. Now if the enemy is hit and the health is not 0 currently, which means this is a fresh hit, so we will call the dead function, change the hit to false and return. Now you may be wondering, there was no hit function in this file. So this is just like high score, will be created in index.html and we'll use it here. But what if the enemy is not hit? Then we need to update its location based on its speed and direction. So first we'll check if the enemy health is 0 or not. If it is, then it will drop down to the ground. But if it is not, then we'll check the direction change. If it's 0, which means we need to change the direction, otherwise we'll move on. Now we'll switch the direction of the enemy. Remember this variable which we created when we were generating our enemy? So we'll use it to detect where we need to move and multiply -1 based on the direction. Finally, we will create a method which will check if our enemy has reached the boundaries or not and update our lives based on that. If our lives have reached to 0, then it will pause the game and change our screen to game over. Finally, we will check if our enemy has reached the right or left corner of the display. If it has, it will change the direction to the other direction and continue until it reaches the top. Now let's take a look at the index.html file. Now this is the most important file and it is quite small as well. So first we'll start off with basic template, then we'll add some style, and then we'll add the packages which we need. So we need two, socket and our main module. Once we have these two, then we will add some basic JS. So remember high score and hit? Yeah, we'll create them here. Next up, we'll create some sockets to get the high score and to check for a hit. If our high score is -1, that is, this display is rendered first time, we'll emit using our socket to get high score. This emit function will be cached by our index.js and then it will emit set_high score with the high score. Now the game over screen is exactly the same as menu, so I hope you can create that on your own. So we will move on to the next part, that is our gun. Inside our gun we have 3 files, so let's start off by index.html. We'll start off with basic template, then we'll add basic libraries. So here we are using pj5 and also sockets. So next we'll add sockets and our JS file. So this sketch.js is our main JS file here. We'll create some variables at the beginning, also initialize socket here, and then set some constraints. So we don't need audio, so we'll put audio to false, and video type will be our environment. So basically our back camera, not the front one. Next up, we'll create a setup function, create our capture, which basically creates a canvas where everything which we capture is displayed. We'll hide the capture which is shown by default and show our own capture canvas. Next, we'll create a button. This button will be calling a function take snap. This snap function basically takes a snapshot of whatever that there is in front of camera. We'll also add some vibration just for some feedback, and this method will call another method called detect center. Now this detect center is this function which will detect if there is the duck at the center of the screen or not. So this detect center will start off with the simple variable and load all the pixels from the capture. Then we'll check if the pixels exist or not, just in case they do not, and then we'll loop over all the pixels. Now pixels are arranged as RGBA, which means red, blue, green and opacity. So we will iterate using I plus equal to 4. Then we'll put a if condition to only check at the center of the display, and if there is red color, we'll turn the hit to true, otherwise we don't do anything. This is the most important part of this code. You may need to update the values here as different cameras capture different colors for the same picture. Finally, we will emit whether it was a hit or not, and then we'll update the picture inside our canvas as well. And that's pretty much it. Now we are ready to run this application and it should work. And this is pretty much it. We can run our application inside the terminal, and then we should be able to open our gun inside our phone and our game inside our computer. So for building the gun, I will be using some cardboard which I got from a lot of Amazon and Flipkart boxes. First off, I'll create this basic design inspired by Chris Vector. Now I need two of these, one for the leftmost layer and one for the rightmost layer. Now I'll add some basic pieces of cardboard in between these two layers to give it more strength and durability. And finally the gun looks like this. I also took out this phone clamp and connected this to my gun using a nut and bolt. Now this is quite sturdy, but I'll add some extra toothpicks or sticks just to give it more strength. And this is how the button looks inside my phone if I open up my URL. And this is a picture of an enemy hit using this button. So you can see you can also use your phone as a viewfinder. Finally, this is everything attached. It is quite sturdy, and even if you move, it won't break off quite easily. So that's all for this video. Hope you enjoyed it. Please give a thumbs up if you did and do subscribe.